Questions 21 to 25 on the 2006 Grade 7 Gauss Math Contest. Gail is a server at a restaurant. On Saturday, Gail gets up at 6:30 a.m., starts work at X a.m., and finishes at X p.m. How long does Gail work on Saturday? Well, let X equal some number. So if she gets up at 6:30, perhaps she starts work at 9 a.m. So I'll let X equal to 9. Okay? So if she starts at 9 a.m., then she finishes when? Well, she finishes at X p.m. So she finishes at 9 p.m. So you tell me, how many hours did she work? From 9 to 9, it's 12 hours, right? No matter what you put in for X, as long as it makes sense, as long as it's after 6:30 a.m., you'll get the answer of 12 hours. If you put 8 a.m., if you put 10 a.m., it's X to X. So it will be 12 hours. So number 21, the answer is E. In the diagram, a shape is formed using unit squares with B as the midpoint of AC and D the midpoint of CE. The line which passes through P and cuts the area of the shape into two pieces of equal area also passes through the point. So our job is to figure out which one of those letters do we draw the line through. And when we do draw a line, it will cut it into two equal pieces. So for example, let's say I chose E. That means when I draw a line from P to E, then when I look at those two shapes, they've got to have equal area. All right, let's see what we get. Well, this unit square has obviously an area of 1. This unit square has an area of 1. Now I've got to figure out the area of this triangle here. That's pretty straightforward. 1/2 base times height, which is 2 times 2, which is 2. So this triangle is basically 2. So this side looks like 2 plus 1 in terms of its area, and that's 4. All right, let's figure out the area of the other side. This unit square is 1, this unit square is 1, and that is 1. Now I've got to figure out the area of this rectangle on the other side of that red line, and that's 1/2 base times height, which is 2. So the area on this side looks like 2 plus 3, which is 5. All right. Well, the 5 and the 4 don't match, so E is not my answer. All right, no problem. Let's try another letter. We know E is not the answer, so let's try D. Hopefully D will be the answer to our question. So again, now the same philosophy. I'm using the areas and comparing them. Hopefully they match. This unit square is area of 1. This unit square has an area of 1. Now to figure out this guy, we've got 1/2 base times height. This time is 2.5. So that looks like 2.5. So the area on this side is going to be my 2.5 that I just calculated, plus those 2 unit squares, and that's 4.5. Okay, now let's turn our attention to the other side. Okay, this is a little bit trickier. I've got to cut this in half like that to figure out that triangle. So this triangle right here. 1/2 base times height would be 1/2 base, which is 2, times height is 2.5. So that just looks like 2.5. And then this unit square is 1. This is half of a unit square, so 0.5, and half of a unit square, 0.5. So that looks like a total of 2.5 for this, plus 1 plus 0.5 plus 0.5, and that looks like 2.5, 3.5, 4.5, 4.5. There you go. Our areas match. This 4.5 matches with that. So the line that cuts that shape into two equal parts passes through D. So number 22, the answer is D. In the addition of two-digit numbers, each blank space, including those in the answer, is to be filled with one of the digits 0 through 6, each used exactly once. The units digit of the sum is. All right, well, one thing I quickly noticed is that when you add up these numbers, they give you a three-digit number, right? So although they don't say that in the question, I am assuming that this first is not a 0. It could be, right? I mean, there's nothing specific in the question, but the fact that it's a three-digit number, I'm assuming that it's not a 0. Because if it's a 0, it would be a two-digit number. It'd be kind of silly to kind of put a number like this, right? I guess you could, but there'd be no real reason to put that box there. So that makes me think that is not a 0. So it's got to be at least a 1. So if it's at least a 1, then these two-digit numbers have to be give a sum greater than 100, right? That's the only way you're going to get a three-digit number. So for example, if I were to take 12 plus 34, that's not going to work. That's not going to give me a sum greater than 100. It's going to give me a two-digit number. So I've got to choose two numbers that when you add them, give me a sum at least of 100. All right. This is all trial and error. So I'm just going to put 6 here, 5 here, 4 here, 3 here, like that. Okay. I have no idea what this number is. Okay, first let's do our initial test. Is this greater than 100? Well, 65 plus 43 is 108. Okay, it passes my first test, but the problem is I've got an 8 there, and 8 is not one of our choices. So that makes me think, okay, that helps me actually, even though I got my first guess wrong. That makes me realize that when I add up these two numbers, it's got to give me a number that's one of these, right? Because previously I got an 8 and that can't work. So I think, okay, no problem. I'll get rid of this 5 here and I'll put in another number. Something plus 3 has got to give me one of these. All right, how about 2, right? 2 plus 3 is 5, and 5 goes in there. And this actually works. Boom, I just got it. So through trial and error, if you think about it in a certain logical way, you should be able to get this without too much difficulty. So 62 plus 43 does indeed include 105, and we are definitely including each of those exactly once. So the units digit of the sum is this guy right here, and that is number 5. So number 23, the answer is D. A triangle can be formed having side lengths 4, 5, and 8. It is impossible, however, to construct a triangle with sides 4, 5, and 10. Using the side lengths 2, 3, 5, 7, and 11, how many different triangles with exactly 2 equal sides can be formed? So the fundamental rule or principle of a triangle, any triangle, is that if you have sides, let's say, equal to A, B, and C, then A plus B must be greater than C. And that's exactly what they're trying to show you in the first two sentences. The first two sentences of this question essentially are telling you this in a sort of an indirect way, I guess. So, using that principle, we have to start making triangles with side lengths 2, 3, 5, 7, and 11. These are our choices. And with the condition that exactly 2 sides are the same. So, isosceles triangles, basically. Okay, let's start with 2. If 2 is one of my choices, I'm going to make that the side that there are 2 of. So now my question is, what do I choose for my third side? Can I choose 3? Well, just look at this principle. 2 plus 2 has to be greater than the third side, so 4 has to be greater than that third side. Well, for which of these numbers is that true? Now be careful, don't choose 2, because that would make this an equilateral triangle. We can't have 3 sides the same, we can only have two equal sides. So I can't choose 2, but I can choose 3, right? Okay, so we got 1. What if I chose 2, 2, and 5, like that? Well, that doesn't work, because 4, if you look at this right here, is not equal or greater than 5. 4 is not greater than 5, so therefore this is not going to work. All right, so that basically is how you're going to do this question, and it won't take that long. So now we've exhausted the 2's, let's go to the 3's. 3, 3, and what else? Can I put a 2? Definitely. Can I put 3, 3, and 3? Okay, don't avoid that mistake, because remember, it can't be equilateral, it can only be isosceles. Can I put 3, 3, and 5? Well, let's see. 3 plus 3, is it greater than 5? And yes, it is. So that works. Now what about 3, 3, and 7? Well, that will not work, because 3 plus 3 is 6, and that is not greater than 7. All right, so we got rid of the 2's, we got rid of the 3's. Now, same principle, we choose 5. 5, 5, and 2, will that work? Sure. 5, 5, and 3, that works. I'm totally going by that, and nothing else. 5, 5, and 5, we can't use that, because we have to have only 2 sides the same. 5, 5, and 7, yep. But what about 5, 5, and 11? Well, that won't work, because 5 plus 5 is 10, and that is not greater than 11. So that's no good. Okay, moving right along here. 7, 7, 7, and 2. Yep, 7, 7, and 3. 7, 7, and 5. And 7, 7, and 11. Let's see, does that work? It does. And then finally we're down to the last one, 11 and 11. Can I use 2? Yes. Can I use 3? Yes. 11 plus 11 is definitely greater than 2, definitely greater than 3. 11 and 11, is it greater than 5? Sure it is. And 11 and 11 and 7, that also works. So now we got to circle, how many did we get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So we got 14 that work with our conditions, and therefore number 24, the answer is E. Five students wrote a quiz with a maximum score of 50. The scores of 4 of the students were 42, 43, 46, and 49. The score of the 5th student was N. The average or mean of the 5 students' scores was the same as the median of the 5 students' scores. The number of values of N which are possible is. So our values for the scores are N, 42, 43, 46, and 49. So our average, or mean rather, either one, is going to be N plus 42 plus 43 plus 46 plus 49, all divided by 5. Okay? And this is N plus 180 over 5, which is basically N over 5 plus 36. And this is our mean, average or mean, whichever word you prefer using. Now, we have to figure out what can N be to make the median also N. So what I do is make a little table. And let's see what we get. So I got a little table here. I'm going to have N, median, and mean. And hopefully we won't have to do too many. So we got N here, mean and median. All right, we got to start somewhere, right? So let's start with 1. Well, 1 is important, well, whatever you want to do, but I like it because it shows you that if you put 1 in, you would get a fractional answer for mean. And therefore, there's no way that can work because the median has to be a number, correct? And therefore, since the median and the mean have to be equal, the mean has to be a number. So we can only put numbers for n that are multiples of 5. That's the only way you're going to get an integer value for mean, and therefore be able to match the median. All right, so let's start with 5. If n is 5, the mean is quickly calculated as 37. And if n is 37, then what's the median? Well, the median is 43. Does this work? No, because remember, our goal is to make the median equal to the mean. All right, so no problem. Keep going. How about if I make the value of n equal to 30? And really, my goal is try to make these means equal to each of these, and that will help me figure out this very quickly. And I guess the quicker way of doing that, instead of concentrating on n, is just put in the mean values, 42 for example, like that. And if you do that, you'll be able to figure out n pretty quickly. If the mean is 42, and that is equal to n over 5 plus 36, you just 42 minus 36, which is 6, and then times 5 is n. And that would mean n is 30. If n is 30, then what is the median? Well, the median is 43. You see how I got that? Now, is the mean equal to the median? No, so that doesn't work. All right, not a problem. Keep going. Now let's try the next one, 43. If the mean is 43, you can quickly calculate n. 43 minus 36 is 7. 7 times 5 is 35. So we got 35. Now, if 35 is the value for n, what is the median of these 5 numbers? 43. And there you go. You just got a value for n for which the mean equals the median. Great. Now we have to see how many more can we get. All right. Let's keep going here. 46 for the median, or sorry, the mean. If you have 46, put 46 here. 46 minus 36 is 10. 10 times 5 is 50. All right. So if 50 is n, I'll put 50 over here now. What is the median? Median is 46. Does the mean and median equal each other? Sure. All right, we got 2. Now, the n can never be greater than 50 because the maximum score is 50. All right, so do we just say, okay, we got 2 values for n, circle E, and then end the contest? No, please do not do that mistake. We've got to look at other possible values. Now, the good news is that you don't have to go through 49, 48, 47, 46 for n. Why? Because remember, we talked about this earlier. In order for this to work, n has to be a multiple of 5. That's the only way we're going to get an integer value for mean. And because the mean has to equal the median, and the median must be an integer, right? It's just going to be the middle value of a set of integers. Then, therefore, considering all of that, n has to be just a multiple of 5. So we only need to look at multiples of 5. So I'll look at 45, I'll look at 40, and I think that should be it. Because, what the heck, we can, any other multiples of 5? 50, 45, 40, 35, 30. Oh yeah, below 30, so 25, but that's certainly not going to give us a proper answer. Okay, let's work with this. So n is 45. Right? So let's do that. 45 for n. So 45 divided by 5 is 9. 9 plus 36 is 45. So therefore the mean is 45. Okay? And then what's the median if the value for n is 45? Well, the median is 45 also. Great. Look at that. See what I mean? By plugging in more values, you get another answer. I've got another value for which the mean is equal to the median. Let's keep going here. We'll probably only have to do a couple more, and we should be done with this question. So now let's try 40 for n. If n is 40, 40 divided by 5 is 8. 8 plus 36 is 44. So that means my mean is 44. If n is 40, what's my median? It'll be 43. Okay, that doesn't work. All right, I think that should be it. But let's just try 25, just to be thorough. It's certainly not going to be a correct answer choice, but let's just see. If it's 25, we've got 25 divided by 5, which is 5. 5 plus 36 is 41. So that means my mean is 41. 41 goes here, and therefore my median is 43. So there you go. And I hope I have shown you the right way of doing this. Please don't circle, 2 and move on. Exhaust the question and get all 3 values of n. And those values are right here. So the answer for number 25 is 3, and that is choice A.